We have two constraints on T so far. You've seen what iEntity can do, which is force T to implement the iEntity interface. Now let's talk about the class constraint. First, let me remove the class constraint and just ignore all the current errors that appear. I want to focus on a new error, and I'll do that by implementing find by ID, which we haven't done as yet, but let's try it out. First, I want a default result for T. Let's say if we're not going to find a T by that ID parameter, we'll assign a null and return that entity. But this results in an error, as you can see by the red squiggly. The C# compiler isn't sure that T will be of a type that actually accepts a null reference. Without the class constraint, T could be a value type. This would be like saying int x equals null. It's just not possible, because value types cannot be null. A more proper way to achieve this with a generic type is to use the default keyword. So I can say, please give me the default value of T. If T is a reference type, a null value is assigned. For value types like int and double, the default value is all bits off. That's usually a 0 for numerical types. Now if I put the class constraint back in, then I can continue to use default, or I can use null, but here's something you should know. If you have a class constraint, it has to come first in the list of constraints. You can see right now Visual Studio has detected that this is an error. So I need to take class and move it to the front, ahead of iEntity. And now we're back to forcing T to be a reference type. If you want to go the other direction and force T to be a value type, like an int or double, then you can use the struct constraint. So you can use one or the other, struct or class, but not both, obviously. You either want to force T to be a value type using struct, or you want to force it to be a reference type using class. You can also have as many interface definitions as you like. So you can have the iEntity interface. I could also say that T has to implement the iDisposable interface, the iAnything interface. T will need to implement all of the interfaces that I list here. Some of the low-level interfaces of .NET are useful here. Interfaces like iComparable. That allows you to compare two objects of type T that are being passed into methods in the generic type. You can also list a class here and say that T has to be assignable to this type. Now if I do a quick build, you'll notice that I have a few incompatible things here. First of all, person must come before any other constraint, so I'd have to move person ahead of iEntity. But notice this second error in the list. I cannot specify both a constraint class and the class or struct constraint. Essentially, the compiler is smart enough to figure this out. If I take person here and move it, well, now the C# compiler is smart enough to figure it out. Since T has to derive from person, and person is a class, T must be a class. Very simple reasoning for the C# compiler. Also, if I had a second type parameter here, let's call it T2, then I could use that in the list of constraints. This would essentially be saying that T has to be assignable to a T2. So it must be a T2 or must derive from T2. And typically you use these types of constraints to force some sort of base class. It would be silly to use a generic type parameter and then constrain T to be a specific type. That's just not what the purpose of generics are for. You want to vary the type somehow. So typically you specify some sort of base class, either using another generic parameter or the name of the base class. In this case, I don't want SQL repository to be restricted to just things that derive from person, so I'm going to put the class constraint back. And again, the goal of all these constraints would be to force T to have certain features or APIs so you can invoke methods or set specific properties inside the implementation of a generic type, like SQL repository of T. But there is one feature of T that I cannot control with an interface or class constraint, and that's the ability to create a new T. So inside of find, suppose for some reason I wanted to create an instance of T. And I can certainly type new T, but the compiler is going to complain and essentially say that it cannot be sure that T is something that it can create using a new operator. It just doesn't know if T is going to have that capability, and that's not something that you can describe through an interface or a base class. So there is also, in addition to the constraints that we've seen so far, a new constraint. The new constraint is the word new, there is parentheses after it, and it always has to be the last constraint. So the class constraint or the struct constraint always comes first if needed, the new constraint always comes last. And with that constraint in place, the C# compiler will always check to make sure the type T has a default constructor. It's something that can be constructed without needing any parameters passed to the constructor. And that would give me the ability to create a new T inside of code. And now that you've seen all the different possible constraints that we can apply, let's finish off the implementation of SQL repository. First, I don't really need a new constraint, so I'll remove that. But let's finish off the implementation of delete, which is very simple because I can just call set.remove and pass in the entity that I want deleted. Find, also very easy because the dbset API includes a find method. All you need to do is pass the key values to that find method. In this case, we just need to pass ID. If you have a composite primary key, you can pass in multiple values. But the dbset will go out and find that record in the database, map it to an object, and then return that to us. And now we have a complete SQL repository. Let's just do a quick test to see if it works. I want to go into the program and create something that will query employees. I'll give it the employee repository to work with, use control period to create the method, and inside of here, I want to find the employee with an ID of 1. So I will find by ID 1. And that's not guaranteed to be there. The entity framework might return null for that. But I'm pretty confident, given the way we tear down and destroy the database and recreate it from scratch every time we run the application, that that employee will be there because of the way the entity framework sets up primary keys to be identity values by default. So I'm assuming I'm going to find the employee and I'm going to print out the employee name. Let's run the application and see what happens. And again, we have 2 employees and the employee with an ID of 1. His name is Scott. So the application is still working. We have a good implementation of SQL repository of T. And now 2 more quick tips about generic parameters and constraints. First of all, going back to the scenario where I have 2 generic type parameters, how do I specify constraints for the second generic type parameter? That's done using a second where keyword. So I could say where T2 is a class. And you can have as many constraint lists as generic type parameters. But since I don't need T2, let me remove that real quick. And then the other tip, a lot of people want to know if these constraints should be applied to the interface. Because interfaces can have generic constraints, it's perfectly legal to say iRepository of T, where T has to be a class, and implement iEntity. But in general, I avoid this. I think constraints are really about implementation details. It's specifying requirements that SQL repository needs to work. And since interfaces don't have any implementation details, I usually leave constraints off. But that's just a matter of personal design style. And now that we've covered constraints in detail, there's one more thing we should know about generics, particularly when it comes to interfaces, and that's the concept of variance.